All right, so I'm recording now. So Caitlin has had some really good questions about this inference with proportions and means. This is the most probably important chapters that we cover in the text. So it's really good that you kind of thoroughly go through these and understand them. Even if you got them all done, these are good ones to go back and like hit similar exercises to try. And as you prep for your chapter 7 through 9 exam, these will be the most relevant to what's going to be on that test. So what we're going to do now is very similar to what you might see on your exam at the end of this week. So, and Caitlin has sent me an example, or we found an example from section 7.1, number 10. So I'm going to do this, and tell me, can you see that problem?
Yeah, looks good.
Okay. All right, so this is number 10 on section 7.1. And I'm just gonna talk through it and then kind of questions you should ask yourself to know what part of StatCrunch should I even use, or what formula is this, okay? So it says a study of 420,004 cell phone users found that 0.0324% of them developed cancer of brain and nervous system. Prior to the study of cell phone users, the rate of such cancer was found to be 0.0337 for those not using cell phones. Complete parts A and B. So first thing they want to do is just find a confidence interval for the true proportion based on this study. So how about if I just do that on StatCrunch? Is that okay? And then I think what I'll do is, even if they don't ask us to do a hypothesis test, I'm going to go ahead and do that as well, okay? Because we can use this problem as a hypothesis test. So let's go ahead and just do the confidence interval first. So all of a confidence interval is we take a sample, and that sample we know comes from a population, and we know that sample should be able to tell us something about the population it comes from, if it's random and representative and all those things. But it's never going to be, we can't ever be sure that it's exactly that. So that's why we say, we know it's somewhere in this interval. And that interval is dictated by the level of confidence and how large your sample size is. And that's what the formula would portray. So on this one, I'm going to go ahead and do a 90% confidence interval for the percentage of cell phone users who develop cancer, okay? So we've got this sample right here, right? And I'm going to ask one or both of you, because when you're doing this in StatCrunch, you need to have an actual count of people that would have been successes. So if one of you would be willing to take 0.000324, because that's the percentage as a decimal, 0.30324 times 420,004, that would be the number of successes. So if one of you could do that while I pull up StatCrunch.
289 people.
Cool. That's awesome. All right. So let's go ahead and I'm going to go over here to StatCrunch. I think I've got it open right here. So I'm going to go to Stat, and what do you guys think I should go to? What are we talking about?
Stats.
Very good. So really, if you're going to be talking about proportions, you know where to go. If we're talking about means, we're typically going to go to T-stats, okay? So with proportions, do we have one sample or two samples?
Two samples?
Well, I only saw one survey, so I really only have one sample here.
Okay.
I do know a population proportion that I could compare it against, like historically, but that's the population proportion, not the sample proportion. So I only have one sample. Now, do I have the raw data or do I have the summary?
The raw data.
So I don't have the raw data. I don't have 420,000 data in StatCrunch. But I do have the summary of the information. This is typically what you're going to have in these problems. Sometimes you actually load the data into StatCrunch and have the raw data, but most of the time it's going to be a summary of that information. So, and even if you've got your formula sheet, that the 2019 formula sheet, and you go to z-score for one proportion or confidence interval for one proportion, you can actually write these steps down right on there. you could say, here's how I would do this in StatCrunch. Proportion stats, one sample with summary or with data, whichever one you does. So that might help you. But as you're doing them, you just get more intuitive about what area to navigate to. So you're really asking yourself 3 questions whenever you're doing these inference problems. And this helps you get through the formula sheet or through StatCrunch. Am I talking about means, proportions, or deviations? Which one is it? Means, proportions, or deviations? This week's deviations. Am I talking about confidence intervals or hypothesis tests, which gives us, this will give us both options. So that's not that critical in StatCrunch. But really, then the next question is, how many samples do I have? If I have one or multiple. So we have proportions, one sample with summary. So let's click that. And how many successes did you say we had? You said 200 and what?
Let me look at my calculator. 289.
289. And the number of observations was what? 420,004. Is that right?
Yeah, I think so.
Why did I remember that? I don't know. So how about, are we doing a hypothesis test or a confidence interval?
Confidence interval.
So click that. And what level of confidence was it?
I think yours was 90%.
Mine was 90. And then we hit compute. So we are 90% confident that the true population proportion of people that get cancer that use cell phones is between, that would be what, 0.062 and 0.075%. Cool? So I'm going to go ahead and type that right into StatCrunch. 0.0. Some different places they want.
Oh, I realized what I did. So I plugged it in there correctly, but I was just putting the decimal. I wasn't making it a percentage.
Oh, so you just didn't move the let me see if I can find that.
Yeah.
Sorry.
I didn't move the decimal.
Oh, I'm making, there we go. So you just didn't, you just put that down instead of making it a percentage. Okay.
That's exactly what I did.
Cool. So, so for fun, let's do a hypothesis test with this. So let me go back to the problem, okay? If I can find it, sorry. There it is. Okay. So here's how you could, here's how I would ask, this would be a pretty typical question you'd see in your test. Except I would ask you, and if you look at when you're studying for the exam, you see how I've asked it in previous semesters. I would ask things like, I'd give you the scenario and I would ask you to do both a hypothesis test and a confidence interval and determine the type 1 and type 2 errors. So I kind of combine all of that thinking into this one problem. So I'm just going to walk through that. How's that sound?
Sounds good to me.
All right. So our null hypothesis is what we think what would be the population proportion. So our null hypothesis here would be P equals right here, 0.000337. Okay. So we believe the population proportion, this is like just in general, the population of people in this area, United States or wherever, that's the proportion of brain or nervous system, cancer of the brain or nervous system. Okay. Our alternative is that we could have an inclination that it's higher or lower or not equal. We're probably most concerned with cell phone users if it's higher. So if I was writing that, I would say, and our alternative hypothesis is P is greater than 0.000337. How does that sound?
Sounds good.
All right. So now our next step is to find the test statistic. And this is when you go right to StatCrunch. So I'm going to go back to StatCrunch here. Hopefully go back to StatCrunch here. And the cool thing is I already got this data typed in. This is a little cheat. If you want, go to options and just hit edit, and it keeps all that in there for you. But instead of doing a confidence interval, now I'm going to do a hypothesis test. And what's my null hypothesis? I said it's what? 0.0003, what was it? 33 what?
I think 334.
All right, let's do that. Cool. And so our null is that, our alternative is, and I'm going to say greater than. I'm going to make it a one-tailed test. If it's two-tailed, I don't freak out too much on this exam about that. If you end up taking the comprehensive final, I'll be a little more picky about it, but it's not that big a deal. So I'm going to go ahead and hit compute. And there we go. We found, because our sample proportion is 0.00068, which, and with this large of a sample, we got a z-score of 12.55, which is essentially a p-value of 0. So statistically, this is very significantly different. So since then you'd say we got our p-value, which is essentially almost 0, and we'd say since the p-value was less than our alpha level in this case, which is not the best method of doing this, but this is the current methods we're using. What I'd rather ask is, do you think that you are observing a very rare thing if the other population proportion is true? If it is true that it's 0.0003, and I went out and found a sample of 420,000 humans that was 0.00068, that's weird, okay? That the probability of that happening by random chance is super low, which tells me there's probably something going on here. Now, we're led to believe, because all of these people are cell phone users, there could be lurking variables. Maybe all cell phone users also, I don't know, work in neurology, I don't know, or something like that, around radiation or something, I don't know. So there could be other reasons that would explain the statistical difference, but based on what we've seen here, we probably have sufficient evidence to reject the null hypothesis and say there is a significantly higher rate of brain and nervous disorders with cell phone users. And that would be our steps. So number one, write the null and alternative, got it. Find your test statistic, got it, 12.5. Find the p-value, got it. Determine if you reject or fail to reject, yep. And then explain that in context. We reject the null hypothesis because p is low. What does this mean in context? In context, that means we have significant evidence that there is a higher rate of brain and nervous disorders amongst cell phone users, something like that. And that would be a hypothesis test. Another thing I might ask is, what's the potential type 1 and type 2 errors here? A potential type 1 error is when we reject the null hypothesis, but we should not have. That can happen. So in this case, the potential type 1 error, we would say, yes, we reject the null, cell phone users have higher rates of nervous disorder. But if that's wrong, then I would say, yep, reject it, it's higher, but it's really not. You're like, well, don't make that error. Well, that's what we don't know. That's why this isn't a perfect way of figuring stuff out. It's the best we can do with the information we have. Type 2 error is to fail to reject the null hypothesis when you should have rejected it. So you'd say a potential type 2 error, and say, nope, it's not. Cell phone users are not significantly higher than the general population, but in fact, they really were. That would be a type 2 error. Okay, so I went through that. Honestly, is about a problem like this is a quarter of your exam that you're going to be taking over these chapters. So this is a very good one to go over. And I'm going to stop sharing. Okay.
Awesome. Thank you so much.
Is that what you're looking for?
Yeah, I think that pretty well covered it. I was doing okay with these types of problems, but this one really threw me off, mainly just because that percentage, like I said, I just didn't convert it back to percentage.
I will blame that. So like, let's say in your test, you write it 0.000, right? I'm going to count that right because it's correct. I'm not, my stat lab gets picky about the format of your answer, doesn't it? Even if it's the equivalent. I'm not going to be that way. So if it's the same number, it's the same number.
Okay, cool.
Yes. All right. That's a great one. Alex, Caitlin has tutoring in a little over 5 or 6 minutes, I think, or 8 minutes, something like that. So she's just getting a little help before she goes in with her tutor at the urban campus, which is awesome. Thank you for seeking that resource out. So I've got about 6 or 7, 8 minutes that I could spend with you as well. So Alex, how about you? Any questions about the one I just went over, one that's related, or maybe some of the new stuff we're doing this week, or what the test is going to be? Totally up to you.
I don't have anything on the last chapters we did. So
Okay. How about on deviations? Have you got to start on that yet today? I know it's the very first day that we're working on it, but with the, do you know where the,
yeah,
How about if I show
Go
you
ahead.
where the chi-squared calculator is and how
Sure.
to use that? Because that will become
Sure.
valuable this week. And how about if I just do that for both of you? So I'm going to go back to stat. I'm going to share my screen. And there's a video on how to do this in Blackboard too, but I'll kind of give my own maybe nuanced approach to it here. So I'll share that. All right. Can you see StatCrunch again here?
Yep.
Yep.
Right, so I'm going to go stat. And obviously you've been here with calculators. You've been doing the normal calculator. With means, we use the T calculator. And with deviations, we're going to use the chi-squared calculator. So I'm going to go ahead and click that. So this is what we call the chi-squared distribution. It's a measurement essentially of variability. Right? There's always some variability. And if you're not detecting any variability, you're just not looking hard enough, or your instrument isn't tuned enough to pick up the variability. Like even, I don't know, making this ring, right? They manufacture this ring to be a certain diameter. None of them are exactly the same, even though they look the same. But if you looked close enough, there's slight variability between every one. Is that helpful? And just, what variability is. And the chi-squared is a way of determining essentially what is rare variability or what's normal variability. And this is the distribution. And the degrees of freedom is dictated on how large your sample is. So if I put 10 in here, you get this shape. If I put 100 in here, it looks almost normal, doesn't it? And as the sample size grows, let's say I put 5 in there, really. So you see how, and if I put 1,000 in there, 1,000 degrees of freedom, it almost looks like a normal distribution. So this is another distribution that kind of approaches the normal, kind of like the T does, based as long as sample size improves. But the cool thing is we don't need huge sample sizes to do analysis. So in in deviations, this last section for this week, you're going to be asked to find confidence intervals and determine chi-squared numbers. So I'm not going to go too much into that, but I'm just going to show how to use the calculator. So let's say we went and got a chi-squared statistic of, let's say the sample size was 10, and the chi-squared statistic was 12, and I hit compute. So that's essentially saying the proportion of that are 12 or below is about 71% of the time. If I flip-flop this, that's the proportion that would have that much variability or more if it fits this model. So if I go out and find a chi-squared stat of 20, let's say, now it's only 2% greater. And typically we're looking to the right on this distribution, percent greater than. The one thing that gets a little tricky is when we're doing confidence intervals. So if I hit the between button here, and I want the between part to let's say it's a 90% confidence interval, I can type in 90, and it gives me what we call the chi-squared left and the chi-squared right, which it may ask you actually on your homework. What's the chi-squared left and the chi-squared right? So if I'm doing a situation where the sample size is 11 and it's n minus 1, so I went out and measured 11 bolts, right? And I took the measurement of each bolt and compared it with what was supposed to be, and I found that difference, and then you squared it, and you divided by what you expected, and you did that for all 11 bolts. This 90% of the time we would expect this would be the variability, somewhere in this red. And so the formula requires you to find chi-squared left and chi-squared right, but we could just use StatCrunch to do that exact same thing. So, and typically you would have the data with that. So I don't know, should we jump? We got a few more minutes. Should we jump right into a homework problem maybe from that section? Maybe I'll jump.
I got one pulled up here.
Oh, great. Which section is it and what number?
It's a 7.3 question 2.
All right, let's do that one. 7.3, number 2. Cool. All right, given that information, degrees of freedom, critical values, this is exactly what we're doing. Is it reasonable to assume that a simple random sample has been selected from a population with a normal distribution of nicotine and menthol cigarettes as 90% confidence with N equals 20 and S equals 0.28? So the degrees of freedom is just going to be N minus 1, right? So that's going to be 19. And the chi-squared left and chi-squared right. So exactly what we're doing with that calculator, we're going to type in 19 for the degrees of freedom, and we're going to type 90%, and it should give us the chi-squared left and right. So I don't know if I still have this pulled up. Man, how do I find this? Anyway, I'll just do it. Stat, calculators, chi-squared. So we go 19 degrees of freedom, and we're going to go between, and we know that it's supposed to be 90% between, and we hit compute, and there's our chi-squared left, and there's our chi-squared right. So if we do this analysis and we find out the variability is between essentially 10.117 and 30.1439, we would say 90% of the time that fits. But if we find variability outside of that, we might say, you know, only 5% is below and only 5% is above. But if we're doing a 90% confidence interval for the true, let's say, variation, and that could be just the mean or standard deviation, then those are the numbers we'd use for that. If we wanted to use StatCrunch to actually do this, I don't know if they give us that. Yeah, maybe not. That's not it. Is this it? That's two proportions. There we go. So is that what you're looking for in that one? I think was that number 2 you said? Yeah. So
Yeah, it looks good.
yep. And then the next ones will actually show you how to do the confidence interval ones, and there's videos on that too. But I can stay on a little longer, but I know, let me hit stop sharing here. Hold on. So Caitlin, how is that a good start? We're having another office hour Friday afternoon. I don't know if that works, but if you want to do another one another time.
Yeah, that's a phenomenal start. Thank you. I'll be working Friday. I usually work all throughout the week, but Wednesdays will now be my new days off. So I'll have that at least.
All right. Well, just reach out, hit that Ask My Instructor button. And then like you were saying, you were kind of like Googling certain videos. We've kind of vetted a lot of things, and so then I can like the ones that are on Blackboards, I think are maybe not the best, but we feel like they do a good job of explaining how to do it, and probably a really efficient way to explain it.
Okay, cool. I'll definitely check those out some more too.
All right. Well, thank you for being here, and thank your tutor. I'm glad they're there. And say hi from me. I don't know who it is, but you say my Professor Dan, whatever. Maybe I know, maybe I don't, but
will do. All right. Thank you so much.
All right. Talk to you later. All right, Alex, how about you? Is that as far as you wanted to go right now? Or did you want to go through a few more or something a little additional, or does that just get you going?
Yeah, I think that should be just fine for now.
Okay. There's a really good video on Blackboard on how to do the whole confidence interval stuff with deviations too. So that'll show you what to do when you get to those too.
Okay. Yeah, that's what I was going to ask. So it's just on Blackboard.
Okay. Yeah. In fact, here, I'm going to hit share my screen. I'll show you exactly where it's at. Okay. Let's see here. Here we go. So if I go right here, and if I go to, let's see here. This is the 2 sample one of StatCrunch. Let's see here. Maybe maybe it's embedded in one of these in the lecture video. Here we go. Here's a one variance hypothesis test. So this would be a good one, the section 8.4. So if you watch this one, this will go through the whole thing. And like before, the area where we do confidence interval and the area we do hypothesis test are essentially the same clicks, right? You just click on one or the other.
Sure.
Yeah. And so in StatCrunch, that would be, here, I'll show where that is. So we'd go stat, and then we would go to variance stats. That's where we'd find the ones we're doing here. Is it one sample or two samples? So if it's like one sample with summary, you can type in the variance. Let's say it was 25, sample size was 20, and the variance, let's do a confidence interval, and 95%, and there it is. Something like that. So that'll walk you through it, but that's the same clicks. So really the areas we're working through in this chapter are going to be t-stats, proportion stats, and variance stats. Is these three is what we're hitting, these three chapters. Cool. All right. Well, I'm going to go grab some lunch. And so I look forward to, keep shooting me emails or texts and ask my instructors as you're going through these. If you want to do a review, next, I'm guessing I'm pushing the test. This test doesn't need to be done until essentially next Friday, a week from this Friday. The homework needs to be done by Tuesday and stuff, but so that gives people more time. The next chapters aren't nearly as difficult and won't take as much time.
Right.
So if you ideally probably spend, this week hammering through everything, and then if you want to do a review session next week, that'd be awesome.
Sure, absolutely.
All right, is that okay? Answer enough questions?
That's perfect. Yeah, that's all I got.
Okay, wonderful. Well, thanks for being here, and looking forward to see how everybody does on all this. And well, I'll talk to you later.
Great. Thanks, Dan. Have a good one.